My name is Charles Forey, and I'm doing my video presentation practice problem number 9 for exam 2. The problem is y to the quadruple prime minus 4y double prime is equal to x squared. The characteristic equation is r to the power of 4 minus 4r squared is equal to 0, where if you pull out an r squared, it gives you the equation r squared parentheses r squared minus 4 end parentheses is equal to 0. This will give you then two equations which you can then solve for. R squared is equal to 0 and r squared minus 4 is equal to 0. Solving for the first equation, you find that r is equal to 0 and 0, whereas for the second equation you solve for r and you find that it is equal to plus or minus 2. So the complementary function is y sub c of x is equal to c sub 1 plus c sub 2 times x plus c sub 3 times e to the power of 2x plus c sub 4 e to the power of negative 2x. The terms involved in f of x is equal to x squared are x squared and its derivative x and 1. So this we consider now y sub p of x is equal to a times x squared plus b times x plus c. Now to eliminate duplication, you multiply y sub p of x by x squared. This now gives us the equation y sub p of x is equal to a times x to the power of 4 plus b times x to the power of 3 plus c times x to the power of 2. Now by deriving this equation 4 separate times, you then come up with the respective equations for y sub p prime, double prime, triple prime, and quadruple prime. Y sub p now satisfies the given differential equation, that is y sub p to the quadruple prime minus 4y double prime is equal to x squared. Now plugging in the derived equations to this equation, we now get 24a minus 4 parentheses 12a times x squared plus 6b times x plus 2c end parentheses is equal to x squared. Factoring that equation now gives us 24a minus 48a times x squared minus 24b times x minus 8c is equal to x squared. Equating the coefficients, we then get negative 48a is equal to 1, which then gives us a is equal to negative 1 over 48. Also, b is equal to 0, and 24a minus 8c is equal to 0, and plugging in a to that equation, we solve for c, which gives us negative 1 over 16. Thus, the particular solution is y sub p of x is equal to negative 1 over 48 times x to the power of 4 minus 1 over 16 times x squared. So now we know the general solution of the given differential equation is y of x is equal to y sub c of x plus y sub p of x. Now plugging in what we found for y of c of x and y sub p of x into each equation, y of x, y prime of x, y double prime of x, and y triple prime of x, we find the correct equations. Now given the initial conditions, this yields the linear equations as y of 0 is equal to c sub 1 plus c sub 3 plus c sub 4 is equal to 1, y prime of 0 is equal to c sub 2 plus 2c sub 3 minus 2c sub 4 is equal to 1. Y double prime of 0 is equal to 4c sub 3 plus 4c sub 4 minus 1 over 8 is equal to negative 1. And y to the third prime of 0 is equal to 8c sub 3 minus 8c sub 4 is equal to negative 1. Upon solving for these linear equations, we then get c sub 1 is equal to 78 over 64, c sub 2 is equal to 5 over 4, c sub 3 is equal to negative 11 over 64, and c sub 4 is equal to negative 3 over 64. Thus, the general solution is y of x is equal to c1 plus c2 times x plus c3 times e to the power of 2x plus c sub 4 e to the power of negative 2x minus 1 over 48 times x to the power of 4 minus 1 over 16 x to the power of 2. Plugging in the variables, we then get y of x is equal to 78 over 64 plus 5 over 4 times x minus 11 over 64 e to the power of 2x minus 3 over 64 e to the power of negative 2x minus 1 over 48 x to the power of 4 minus 1 over 16 x to the power of 2. Now finding a common denominator and simplifying the equation, we then get y of x is equal to 1 over 192 brackets 234 plus 240x minus 33 e to the power of 2x minus 9 e to the power of negative 2x minus 4 times x to the power of 4 minus 12 times x squared. Thank you.